Hello! How are you? My name's Thomas Brush. I'm the creator of a game called Pinstripe. I'm also working on a game called Once Upon a Coma. I've been making games for 10 years, and it took me a really long time to try and figure out exactly how I could create a melee system. And it wasn't until recently that it really kind of started to click for me. Creating a melee system can be a little bit complicated. There's kind of a lot of moving pieces. Anyone can make it happen, but I think the best thing for you to do is to see a bird's eye view of how this system actually works. So first, I've included a project file for you to download in the link in the description. Go ahead and download that, open it up, and as you watch this tutorial, you can kind of dig around in the files and see how things are working and functioning. All right, guys, are you ready? Let's get started. All right, so the first thing I want to do here is just show you a very basic idea of what we're trying to achieve here. So we've got platforms that you can jump on. We've got AI that you can punch, that jump over you and jump over edges and avoid edges and can also jump up walls. Very basic AI here that explode into particles, and you can also get hurt and launch away. So it's a pretty fun concept. It's actually really enjoyable for a very basic game. Now, the first thing I want to do is just really quickly tell you about the camera. There's no reason to really create a new camera script when you have one out of the box called Cinemachine. So you can just create a virtual camera, and you'll have a main camera and then this virtual camera game object. And these settings here are going to control the main camera. So you have the main camera Cinemachine brain here, and it's being controlled by this virtual camera. And it's also told to follow the player. And I have a previous tutorial that I've done, and I've included that in the link in the description if you guys want to see how we can create that. And we also create parallaxing in that tutorial as well. And we're using parallaxing in this as well. This is custom parallaxing. This actually isn't parallaxing via a perspective camera. It's actually coded inside of an orthographic camera. And we just have these general layers here, basic layers that are exported inside of Photoshop, bring them into Unity, place them in the scene, and Unity is going to parallax those because of a script that we wrote. But again, if you want to see how to do that, check out the link in the description for the tutorial for that. Alright, the next thing I want to cover, and this is where it gets really interesting, is character animation. Alright, the first thing we're going to show you is the characters being animated inside of Spine. Now you can use Spine, or you can use Unity's proprietary 2D animation character rigging system that they just released with 2018. I think both methods are going to work great. I'm going to show you generally how it works inside of Spine though. So basically, we have an attack animation here. We have a hurt animation where it just flashes white, a jumping animation. So you can see we're not actually animating the jump and moving the Y position. All it is a bounce effect. We've got landing here, running, standing. Something I've really learned over 10 years of animating characters is the most important thing for your character for a 2D game is to ensure that you've got a nice bouncy effect with the Y scaling. So you can see the running here has a bouncing effect, and it also has a slight Y position change to make it look like it's running and bouncing. Once you have this general abstract look working for you, you can actually get as detailed as you want and add character limbs and a head and hair, arms, you name it, and your character will look great because that Y position of the shifting of the running, for example, really gives that character a bounce. It makes him feel like he's alive. Even if your running animation kind of sucks, if you have this bouncing animation, it kind of looks good. What's also cool about Spine is we can have different skins. So we could have one set of animations and apply those animations to different skins. So this is my enemy and this is my player. We're not creating two different files for enemies or the player. They're all just one character type with different skins. I think that really saves a lot of time and money in the long run. So once we go up here and just click export and export out our texture atlas and make sure you're setting pack to true. Also make sure that says .text at the end. You click export. So again, you can see that these animations play under certain conditions. So let me show you what those conditions are. Now, this animation state machine is covered in the previous tutorial, so we're not going to get super detailed here, but I want to give you an idea of what we're doing so that you can better understand how the enemies work as well. But what I will show you is how we're actually using the animator and the state machine to better understand how we can play sounds, do cool effects without really writing that much code. So you can see right off the bat, the jump animation here, it has an event, and that event is emit particles. We can also see that the running animation has two events. We have the play step sound, which is going to play the sound of stepping, and then we also have emit particles. So you can see these generic functions are being fired inside of the animation so that we don't actually have to code and wait for when the player's, at a certain position in the animation. We can just do it right within the animation timeline. The same is true for landing. We're playing a land sound. Jumping, we're playing the jump sound here. Now guys, a lot of you might be wondering how a lot of the sounds in my games come about, the punching sounds and the hitting sounds. I find a lot of sounds from freesound.org, but I also find a ton of sounds from a website called productioncrate.com, and they are actually supporting and sponsoring this video. They're helping my channel out, so please head on over to Production Crate, see if the sounds available on that website are for you. They really are amazing. I've been a subscriber to their website for 2 years. I love the content that they produce. It's great toolbox for your game, so take a look at the link in the description. Thank you, Production Crate, for supporting this video. Now, all of these functions are available inside of a very generic class that I wrote called animator functions. So if we open up animator functions, you'll see some very basic functions. These are not hard functions to write, but I use them all the time. So for example, we have a play sound, which it just includes a parameter for an audio clip. So we can actually choose what sound is being played inside of the animation timeline. We also have emit particles, and it's just going to reference a particle system up here that we define, and it'll emit particles. So a good example of this is every time that the player hits the very beginning of an animation, when they're in the running state, as it loops, those particles will emit each footstep. Also, we have a screen shake function which references our camera effects and shakes with a certain power. So as you can see, some very basic animations here that are being fired from events inside of Unity's timeline. So again, we can take a look and see how this is actually working. So let's pull up so to show you how this is actually working, you can see as we're running to the left, for example, you'll see that loop. And when that loops, it's firing those events inside of these animations. Now, just to clarify, we also have some layers here inside of our player animation state machine. And we have the player movement here. And then we also have the attack, which is just a simple, every time I click, it plays that attack. And you'll notice that it's set to a weight of 1 and a blending mode additive. And then also, we have a simple hurt layer, which plays the hurt animation. So as you can see, we don't add these animations to the move. So that's the really cool thing about layers, is they allow you to animate certain parts of a character. If you wanted to just animate the legs, for example, you could create a legs layer. But for me, all I have is move, attack, and hurt. And those are all inside of the same state machine. Now, the player movement C# script was actually covered in the previous tutorial, so if you want to see how that was written, please take a look at that. But what I really want to focus on here that makes this game a melee game is the AI, the enemies. You'll notice that my enemies here are almost identical to our player. They're really about just about the same, but there's a class here called enemy base, and it's almost identical to the player script. So I'm not going to cover everything that's going on in these scripts. I'll leave that to you to open up these files and to dig around and try and understand exactly what's going on. But I think I want to explain the basics of AI character movement. So most AI in classic Nintendo games functioned very simplistically. So I have two enemy types here. We have a bug, and then we have a zombie. Let's change it to bug, and I want to show you exactly what happens. You'll notice that they don't follow me around. They just sort of pivot back and forth. So they detect when they hit an edge, just like that, and then they reverse their direction. Very straightforward, nothing crazy. Or if they hit a wall here, you'll notice they go backwards. Very basic. Now, if I change them to zombie, they're actually going to jump over walls and ignore edges. See that? So now they're going to follow me. If they're activated within a certain range, they'll follow me. There they go. But if they're deactivated, if they're not within a certain range, they'll go back to that bug state. See that? Hitting walls and reversing back. This guy's following me. And he'll reverse. Yep. So if you're within a certain range, they'll chase you, just like a zombie game. See that? So let's first cover how that bug enemy type actually works. Believe it or not, the bug one was probably the more complicated script to write. So really quickly here, all I'm going to do is show you how we're doing ray casts. Now, to really sort of make this as easy to understand as possible, we're going to create multiple ray casts here. We have a right wall ray cast, a left wall ray cast, a right ledge ray cast, and then a left ledge ray cast. Now, in theory, you could have this all be one ray cast and shoot it out of different directions, but I really wanted to show you each individual one. So if we go down to our ray cast section, we're going to have some ray casts, and you can see this comment here, that check for walls, right? So this checks for walls. And then this one checks for ledges. Checking for walls was the first thing I did for the bug type. And all we're doing here is we're casting a ray cast in the position of this character. And we're casting it to the right. And we're ignoring a lot of certain layers. So we're ignoring, like, for example, we don't want them to collide with each other. So they're going to ignore other enemies. And then we're also just going to draw that ray so I can show you exactly where the rays are being drawn. And then you'll see right here that if right wall dot collider does not equal null, and if we're not going to follow the player, aka be a zombie, just flip the direction to the left. And then this one here, it's the same exact script, but it's being cast to the left. And that ray cast is being drawn, and it's going to be the color blue. And it's basically saying if the left wall collider does not equal null, aka if we hit a wall to the left, simply flip the direction to 1. And so let me show you exactly what this looks like inside of Unity. So you'll see if I hit pause here, you'll see the ray casts are being drawn. There's the left ray cast, and there's the right ray cast. So if we go down to this guy here, hit play, you'll see his ray casts are hitting the walls and reversing. Notice how these ray casts are detecting if they hit a wall. Now, a lot of people might be wondering, why don't you just use on trigger enter or on collision enter when you hit a wall? Ray casts are really great because they help you know which side of a wall you're hitting. Are you hitting a wall on the right side, or are you hitting a wall on the left side? They also allow you to not actually collide with a wall at all. So you'll notice that these characters don't actually fully hit the wall. They can actually sort of see in front of them a little bit and then turn. This helps us allow not to get stuck inside of walls. So for example, if he was about right there, maybe left and right might start firing really fast if we're not using a ray cast. So the ray cast really help the character sort of see in advance and make decisions. Now, one of my favorite scripts is the one that checks for ledges. And I always wondered how games did this. I always wondered, how do they know if it's a ledge? Well, basically, let's pretend that you could put a laser in front of a robot and it was pointing downward. If it said, there's nothing in front of me, that robot might say, well, maybe I need to turn around and not go where there's no ground. And you'll see that if we hit play, I can show you exactly what those raycasts look like. So let's go over to this guy. We have a right ledge raycast and a left ledge raycast. Now they're both blue, but you could change the color whichever color you want. And again, these aren't going to be shown in your game. They're actually just going to be shown in your editor. So as this player, or as this enemy runs to the left, hit pause, you'll notice we can increment forward right as this raycast says, whoops, there's nothing there. He's immediately going to move back. Here we go. Change his direction. So it's a very simple script that's checking to see if there's anything on the ground. Not walls, but on the ground. So check for ledges here. We have a right ledge. All it's doing is it has a raycast offset. See, it's offset from the center position. And transform.position.y is the same. It's right on the 0 position. And it's using vector 2 down. So it's creating a vector and going down. And this is just the distance. And we're debugging and drawing that raycast. And so you'll see here, if rightLedge.collider equals null, meaning if there's nothing there, we're going to change the direction. So as you can see, we have very simple, almost Mario style player movement or character animation. Now, to tell whether we're actually going to become a zombie, or AKA... Now, the cool thing about zombies are, and I just call them zombies because that's, I think, the best thing I can describe them. It's a really generic functionality. All we do for zombies are, we say, if follow player is true, the direction at which I'm moving is actually going to be determined by the player difference. Okay, bear with me for just a second. Player difference is being set up here. Player difference basically says, what is the distance between the player and this current enemy? If it's negative, make the direction to the left. If it's positive, make the direction to the right. So that's the first step here. Basically, we're saying the direction is going to change based on whether the player is to the left or the right of the enemy. Very basic here. Now, let's ignore this for now. But this right here is saying if our enemy type is set to zombie, and I'm setting that in the editor, it's going to say if the player is inside of the range, basically the line of sight, then we're going to set follow player to true. If we're not within the line of sight, he's not going to follow the player. Follow player is set to false. So if we go back into Unity, you'll notice this big circle here. See that circle? If I change my follow range, this is the line of sight for the enemy. Ignore this circle in the center that's actually used for sound, but this follow range right here is going to tell the player, it's going to tell the enemy when to start following the player. If the player is outside of this line of sight, this follow range, he'll actually stop following the player and revert back to the bug mentality. Let's take this enemy here, make him a zombie. If he's a bug, he's not actually going to detect whether the player is in his follow range. So let's make him a zombie. And if I run to the right here, you'll notice that we're within the range of his line of sight. Now, if I get outside of it, he's immediately going to stop. Now he's going back to his bug mentality. But if I run back to him, he sees me, starts chasing. And he'll ignore that ledge and jump right off because he's a zombie, right? That's generally how character animation and AI works. Now, guys, if this is confusing you and you really want to look deeper into that code, feel free to click the link in the description to download these project files and take a look for yourself at exactly how they work. And now I know what you're thinking. You're thinking, okay, how exactly does the melee work? Well, let's go ahead and hit play and I can explain how this is working. Believe it or not, it's actually very simplistic and not that difficult to grasp. So if I run to the right here, click, I can actually hit the enemies. Now, what is actually hitting the enemies? That's a really good question. Let's go inside of our player and take a look. Remember the attack animation we did in Spine? What that animation is doing is it's simply rotating the player. All it is an effect. So if we open up that animation inside of Unity, this yellow portion here is basically, I can't actually see any animations happening because Spine and Unity aren't perfectly integrated. So don't worry about that. But what we do want to do is actually add an animation for attack hit. And what attack hit is, it's a child of player, and all it has on it is a polygon collider and a sprite renderer. So you'll notice that if I make the sprite renderer appear for a split second, we can visualize that hit area when we hit play. So all that's happening when attack is played is it's activating this attack hit polygon collider really quickly. And all it is a trigger. So let's hit play. And so the enemy script is going to check and say on trigger enter, basically when I'm hit by this trigger, this red trigger, do the hit animation. So obviously, guys, you could go as complicated as you wanted with this. If you were making a game like Mortal Kombat, you'd have colliders on the feet, you'd have colliders on the head, different types of attacks, different types of power and hit powers. So if we go inside of our enemy script, you'll notice we have a simple function here called hit. So all this is doing is it's receiving a parameter for launch direction, and I'll show you that in a second. And then some effects happen. We have a screen shake effect, which is sort of a built-in effect that is used with Cinemachine. The health decreases by 1. We're setting the trigger for our animation to hurt, and that's for the actual enemies. We're setting the velocity, so we're sort of launching the character in the air a little bit using a launch power, and that's defined by me in the editor at the beginning of the game. Launch is being set to launch direction, which is being passed through here. And then I'm also multiplying it by a launch power, so I can actually define, which characters launch or how far certain characters launch. And then finally, we have a recovery counter, which we're not going to dive too deep into that. But basically what recovery counters do is allows the enemy to lose control a little bit and launch away from the player, recover, and then get back into activity and chasing the player. And then finally, we're checking to see if health is smaller than 0. We're going to fire this die function, which just, activates some death particles, makes those death particles not have a parent so that we can actually destroy this game object. That's basically it. Nothing crazy here. The coolest things that are happening are the screen shake that gives us that good game feel, and then launching the actual character into the air. And the same function applies for the player when they get hit. So as we run to the right, if I hit this character, we get some screen shake, we get that hurt animation, and he launches out of the way. If I get hit, I get launched. So you see this kind of stuff in games like Super Smash Brothers. It's what makes the game feel so alive. And then those particles appear, and then the character just deletes from the game. And having those particles remain there gives it a really cool game feeling of object permanence, which allows you to see, if you've killed 20 characters, you'll have blood particles all over the place. So really cool stuff there. Now the final thing I want to cover, and this is not going to take a long time, is just to give you an understanding of how we are doing this health bar. A simple health bar is going to make the player feel like they're actually in a game. It's crazy, the moment I added this health bar, this game got really fun because you actually want to start avoiding the characters. But you notice we have a simple flash animation, and it decreases and lerps to a certain position with easing. So the way we did that is the first thing I did was inside of Photoshop, I have a UI folder or a UI file. So you can see I have all these cool different UI elements. We don't need that. So you can see we have all these cool UI elements. We have this square here, which is actually that health bar as it goes down. We have this pill, which is the background image. We can use it, create a drop shadow if we want. We don't really use that. And then we have some inventory items. But all we're going to focus on are these two here. Now, obviously, you want to make sure the background is disabled so that when you hit save and open up Unity, you'll see that if you go to our sprite editor and make sure it's set to multiple, you can see we have all these different sprites available to us now. You just have to draw these areas, name them appropriately. So that's the pill, that's the bar, and then all of our other elements, which we're not going to cover. You hit apply, and you'll notice that your elements are all inside as children of this UI object. So we can drag and drop all of these inside of our UI. So you'll notice our UI is a simple canvas, and it has all these different objects to it. Don't worry about any of these classes here. These are for another project I'm working on. But right here, you can double click on our health bar here. Ignore this and this. This is sort of a dialogue system I'm working on. All you need to worry about is this right here. So you'll notice that I have the pill, I have the health bar, and what's really cool about new versions of Unity is it allows us to actually create a mask. So you'll notice that we actually can move the health bar, and it actually masks inside of that pill. And the simple way we did that was we made it a child of the pill and then added a mask. It's really that simple. So the pill is a mask for our square health bar, and we can move it to the left and right. Now, all that's happening with this health, plenty of wonderful functions inside of this UI script, but all I'm really going to show you is inside of the update function here. So you notice that basically all we're doing is we're checking the player's health. We're checking the player's health, dividing that by the max health. So for example, if health is 5 and max health is 5, it's going to be 1. So our health bar width is 1. If it's 1 divided by 5, it's going to be 0.2. So our health bar width is going to be about 20% of the full size. So I wouldn't worry too much about this script here. All this really does is it causes the health bar to smooth at a certain easing speed. So in reality, what we could do is we could comment this out if we don't need it, and all we could say is just make health bar.transform.local scale equal a vector 2, health bar width, and then we're just going to keep the y scale the same. So that's generally how the health bar works. And again, our health is inside of the player, and it decreases every time the player gets hit. So guys, again, this is a bird's eye view of how you make a Melee game. So I've included these files in the link in the description so that you guys can open up these files, follow along with this video, dig around inside of these files, and try and understand exactly what we're doing here with this Melee game. Very simple, fun game. Alright guys, what do you think? Pretty cool, right? It's amazing how you can put a Melee system together with just some simple principles that you can follow. If you guys liked this video, if you thought this was helpful, please hit subscribe, hit the bell icon to get notified of when I start live streaming. Leave a comment below and I can try and answer any questions you have. And then ultimately, guys, finally, guys, I want to let you know that Patreon is the reason why I make videos. So if you want to support this channel, see your name in the credits, or join private live streams, you can head on over to the... If you want to see your name in the credits or join private live streams, you can join the Brush Club, which is a way for you to support this channel, but also communicate with me privately during live streams. Head on over to Patreon and see if that's something for you. Thanks again, guys, so much for your support. I'll talk to you later. Bye.